Which one is your positive? Can you check the positive connection? Where's the red one? Red one. So this is positive. So we got a big dot which is positive, and then we've got a circle around it that's negative. So where's the field going? Radially out, isn't it? That's the field. But we're not doing fields, are we? We're doing equipotential. What's the voltage you're connected to? 4 volts. So what we want to do, we want to see here across this distance how the voltage is changing, yeah? And your graph would be a voltage against R. So let's try it. 0, around 2.7, halfway around 2.3, a quarter 1.7, and you could see that actually that potential decreases as you go further and further away. That's what a radial field is. I think what I'm doing it here. I shouldn't do it in the gap. I should do it where the field is. 1.3, 1.4, 2.15, 2.44, 2.6, 2.7, and 2.8. And you can see how the field is growing, yeah? Right, next, off that, if we now do, so that's a radial field. What do we have here? We've got a point charge and then we've got a plate. So the field is literally going like this. And where would be touching the surface, obviously. If this is positive, this is negative. How would you then get your equipotential? 90 degrees. So initially here is straight, but as you go there, that's your equipotential line. And then we're going to explore that. So on 2.7, 2.7. Can you see it's roughly the same 2.7? But if I come over here and I'm trying to look for 1.2, I'm looking for a 2. So when I come over here, look, it needs to go further up. Can you see that? So you can see that the field, the potential does that, and the field does this, which agrees with what we've done. Next one. Off. One better. So this is like your 2-point charges. Again, can we have it on, please? So the potential is going from high to low. The electric field is this way. The potential is that way. And let's check. 2.3. 2.3. Can you see? Again, this field here off, please. If you have got a positive and you got a negative, what does the field do? They do that. Right in the middle, the potential is like that. But somewhere here, you got to do it 90 degrees. And if that's what I'm trying to demonstrate here. So if we do somewhere closer here, 2.6, and I've got to come closer. No, further, closer. So it does that arc. This is quite small, but your student version will be much easier to work with. Off. And finally, the parallel plate, which should have been the easiest one. I should have started with this, really. So parallel plate, the field's going positive to negative, or whichever way we've got that connected. Where would be your potential now? Perpendicular. Go on, young man. 2.22. Can you see it's roughly there? And you can see that it actually 2. If I go all the way through the middle, it's roughly the same. So the potential is like that. The field is like this. Does that make sense? Right, off. Thank you.